Alright, so hello. So for today we are gonna teach you about proof by induction. So we're gonna go one by one on what is proof by induction and how to do it. So for the team members, myself, my name is Salman Siddiq bin Rusli. So the second member is Yusuf bin Sabri. The third member is Syahid Aiman bin Cik Bujang, and the last one is Wan Muhammad Nakiuddin bin Noruzuki. So let's go.
I will talk about proof by induction. Proof by induction is a mathematical technique used to prove that a statement is true for an infinite set of value. There are three steps for the proof by induction. The first step test the formula for the first allowable value of n, usually n equal 1. Number 2, assume true for some value of n, say k. Number 3, having made assumption in step 2, show that the assumption is still true for the net value of n. That is n equal k plus 1. Okay, proof by induction. There are three steps. The first step are prove all true when n equal to 1. So we take the sentence and take n, convert it to 1. So 3r equal 3 and 1 plus n over 2. So it become 3 1 over equal 3 1 1 plus 1 over 2. So after the calculation we get 3 equal 3. So it is all true when n equal to 1. Okay, the second step are assume true when n equal to k. So we take all the statement, convert n to k. So k r equal 1. 3r equal 3k 1 plus k over 2. Okay, there's a second step. So the last step are prove or true when n equal k plus 1. So first thing first, just like 2, we convert it k plus 1 equal 1. 3r equal k plus 1 1 plus k plus 1 over 2. So it will become 3k plus 1 k plus 2 over 2. So k r equal 1. 3r plus 3k plus 1. So we take this and it become 3k 1 plus k over 2 plus we take this 3k plus 1 and we take the 3k multiply it inside this, so it become 3k plus 3k square over 2 plus with 3 multiply this inside 3k plus 3, so it became 3 over 2 k plus t2k square plus 3k plus 3, then can 32k square plus 9 over 2k plus 3, and 3k plus 1 k plus 2 over 2. We continue this equal 3k square plus 2k plus k plus 2 over 2. Multiply it became 3k square plus 3 plus 2 over 2. Next 3k square plus 9k plus 6 over 2, and lastly it became 3 over 2 k square plus 9 over 2 k plus 3. So it is all true when n equal 3 plus k plus 1. Okay, that's all for me. Thank you.
Hello, my name is Wan Muhammad Nakiuddin, and I will continue where my friend Shahi Aiman has left off about proof by induction. So here we can see the example question is that we have to prove that 1 plus 2 plus sequence plus n equals to n times n plus 1 divided by 2. So first of all, for the solution, we have to do a base case here. So n equals to 1. So replace n with 1 since n is equals to 1. So we got 1 plus 1 times 1 plus 1 divided by 2, which is equals to 1. Okay, so that part is here. And then we have to do the induction step. Now we want to assume that that the formula holds true for some arbitrary positive integer. In this case k. So we have to assume that n equals to k, where k is some positive integer. That is 1 plus 2 plus sequence plus k equals to k times k plus 1 divided by 2. Now consider the sum is 1 plus 2 plus sequence plus k plus 1. And then by the inductive assumption or hypothesis, 1 plus 2 plus sequence plus k equals to k times k plus 1 divided by 2. Now we just have to add k plus 1 to both sides of the equation. which will be 1 plus 2 plus sequence plus k plus 1 equals to k times k plus 1 divided by 2 plus k plus 1, which then we can get k times k plus 1 plus 2 times k plus 1 divided by 2. And then what we have to do is factor out the k plus 1, which we can get k plus 1 plus k plus 2 divided by 2. And so, thus by mathematical induction, we've proven that the formula here is the formula here is proven for all positive integers n, that being 1 plus 2 plus sequence plus n equals to n times n plus 1 divided by 2.
Alright, so let's continue for the next example. So for my question, we got proof 1 plus 4 plus 7 plus 3n minus 2 equals n times 3n minus 1 divided by 2. Alright, so we're gonna go one by one. Right, so for the base case, we have n equals to 1. So it will be 1 equals 1 times 3 times 1 minus 1 divided by 2. Right, so we're gonna go for the induction step, so we're gonna assume that n equals k. Alright, so it would be 1 plus 4 plus 7 plus 3k minus 2 equals k times 3k minus 1 divided by 2. Right, so now let's prove it. So how do we prove it? We're gonna go for n equals k plus 1. So it would be 1 plus 4 plus 7 plus 3 times k plus 1 minus 2. So it will be k plus 1 times 3 times k plus 1 minus 1 divided by 2. Right, so now we add the next term, where 3 times k plus 1 minus 2. So it's gonna be 1 plus 4 plus 7 plus 3k minus 2 plus 3 times k plus 1 minus 2. Right, so now we're gonna use the inductive hypothesis, where k times 3k minus 1 divided by 2 plus 3 times k plus 1 minus 2. Right, so now we're gonna expand and simplify this thing. So it will be k times 3k minus 1 divided by 2 plus 3k plus 3 minus by 2. So we're gonna simplify it. It will be 3k to the power of 2 minus k plus 6k plus 2 divided by 2. And again, we're gonna simplify it again and again. 3k to the power of 2 plus 5k plus 2 divided by 2. So we're gonna expand it at the last. It would be k plus 1 times 3 times k plus 1 minus 1 divided by 2. So by the principle of mathematical induction, the formula is proven for all integers n. So that's all from me. Thank you.
Okay, hi. Let's go to the for next question. We got a question. Proof 1 power of 2 plus 2 power of 2 plus 3 power of 2 plus plus n power of 2 equals n times n plus 1 plus 1 times 2n plus 1 times divided by 6. base case times n equals 1 times. Okay, we got a left hand side equals 1 power of 2 equals 1. And then we got a right hand side equals 1 dot plus 1 dot times 1 plus 1 times dot times 2 dot 1 plus 1 times divided by 6 equals 1 dot 2 dot 3 divided by 6 equals 6 by 6 equal 1. Okay, now we go to the inductive hypothesis. Let's assume the statement hold for some positive integer k equals 1. Okay, this is the equation hold for n equals k. The inductive step. Now we aim to prove that the equation holds. For n equal k plus 1 and equals k plus 1. Okay, so we get a 1 power of 2 plus 2 power of 2 plus 3 power of 2 plus dot 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 plus k power of 2 equals k times k plus 1 times 2k times 1 time 2k plus 2k plus 1 times divided by 6. Adding times k plus 1 times power of 2 to both side of this equation. Okay, so we go to the equation. Okay, we got a k times k plus 1 times 2k plus 1 times divided by 6, and then plus times k plus 1 times power of 2 equals k times k plus 1 times 2k plus 1 times divided by 6. So plus k power of 2 plus 1. Next k plus k times k plus 1 times 2k plus 1 times 1 times divided by 6 plus times k plus 1 times divided by 6 equals k times k plus 1 times 2k plus 1 times plus 1 times plus 6 times k power of 2 plus 2k plus 1 times divided by 6. And then next k times k plus 1 times 2k plus 1 times plus 6 times k power of 2 plus 2k plus 2 plus 1 times divided by 6 equals times k plus 1 times k plus 2 times 2k plus 3 times divided by 6. That's all. And we, after simplifying the expression, it's match the RHS of the equation for equals k plus 1 and equals k plus 1. Okay. By the principle of the mathematical induction, we've proven that for all positive integers equals 1 and equals 1, and then the equation is 1 power of 2 plus 2 power of 2 plus 3 power of 2 plus dot 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 and plus 1 and power of 2 equals n times n plus 1 times 2n plus 1 times divided by 6 and wholes. Okay, that's all for me. Thank you.
Alright, so for the conclusion for today is we already know how to do proof by induction. So let's recap. So the first thing, we need to see the base case, and we're gonna assume first. So when we already have assumption, then we can go through to the inductive step. So all the way we did calculation, all that stuff, and we get our answer. So yeah, that's all from us. Thank you.